At some stage, everyone has thought, do other people see the same colours as them? And the answer to that question is no. So, that was quick, but we know some people have colourblindness who definitely don't see the same colours as we do. Can colourblindness do the opposite and lead to extra human vision? Let's explore how our eyes see coloured light, or rather how a normal person's eyes see colours. Inside an eye, there are 3 sets of cone cells that are sensitive to red, green, and blue light. When the red cones see red light, it tells your brain that it's red, likewise with the green and blue cones. As there are 3 cones, this is called trichromatic colour vision. This allows people to see around 1 million colours. Does everyone have these 3 cones? People who are colourblind may not. Dichromacy is a somewhat common cause of colourblindness. The most common type is when people are born without red cones. As a result, these people describe seeing red as a grey or beige colour, and these people can see around 10,000 different colours. The next aspect of intrigue would be those with 3 types of cones. Do they see light all in the same way? Here is the spectrum of light seen by each of your cones. Your brain processes how each of the cones is seeing the light and mixes them to tell you what colour you are seeing. The graphs shown are normalised, and some people do have different graphs to others. The graphs can have such a difference that they can cause colourblindness. The prevailing cause of colourblindness is a mutated green cone that is shifted towards the red end of the spectrum, and in some groups of population the prevalence is about 5% in men. Colourblindness is more common in men because the red and green cone DNA data is stored on the X chromosome. Men have an X and Y chromosome set while women have 2 X's. So if one of the cones is faulty on the X chromosome, the men do not have anything to back up the data. In women though, this means that they have the data twice, which can lead to an interesting phenomenon. Women receive an X chromosome from their father and one from their mother. Let's say that their father has a green cone that is shifted and their mother passes on normalised cone data. This could lead to a daughter having 4 different cones that all have a different spectrum. When something sees with 4 different types of colour receptors, this is called tetrachromatic vision, and is common in some animals like birds and fish. There have been a number of studies conducted to see if humans can have tetrachromatic vision. Some early scientists of colourblind men noticed that the men's daughters could differentiate different shades of red better than a normal human. In Europe, where green-red colourblindness is more common than other parts of the world, it is estimated that 12% of women have the genetic makeup for a possible tetrachromatic vision. DNA tests can show that women have 4 different cones. There are ongoing studies to find women with actual tetrachromatic vision. However, it is challenging. Women whose tests indicate that they have 4 distinct cones typically don't have any high perception of the interpretation of colours. There are many more aspects of vision than just the cones, which are the sensors of the light. The information still needs to be conveyed to the brain via the optic nerve, which may have bandwidth issues. Also, our perception of colour is affected by cultural and language factors. For example, people who speak a language that have separate words for light blue and dark blue, like Russian or Greek, are better at differentiating shades of blue than people who speak English that just has the one word for blue. In one study, researchers are believed to have found a woman with tetrachromatic vision. She has 3 sons, 2 of which have the green cone curve shifted towards the red end of the spectrum, and 1 son who has normal vision. This would demonstrate she has the DNA for the 4 distinct cones, and her test results show that she could discriminate between mixtures of red, orange and green light significantly better than a person with normal vision. As this study was carried out on a number of women who should in theory have tetrachromatic vision, and only 1 in 20 years indicated as such, it is possible that there is more required than just having 4 distinct cones to see in 4 dimensions of colour. So back to the original question, do people see the same colours as everyone else? No. Some people are missing cones in their eyes, and some people have a different spectrum that each one can see. It's possible that most people have different abilities of distinguishing shades of different colours. I.e., these shades of green may look the same to you, but someone with a cone that is slightly shifted may see them as different. Ultimately, our world is built for the typical trichromatic vision, from the lights in our phone screens to the languages we use to express colour. So having an extra human vision in differentiating colour is probably not that useful in day-to-day life. Thanks for watching, and if you enjoyed this content and want to see more like this, leave a comment, subscribe and like this video. Thanks.